Well, welcome. Glad I got the last slot, always squeaking right in there at the end. Just to kind of go over what I'll be talking about today. So first off, who is Aerobotics? I bet a lot of you guys have already heard of who we are and what we do, but we'll kind of talk about that, why we chose ROS as an integrator, and then how we set up ROS, and then how we actually use ROS. I'll give you guys two examples of projects that we have done with it. So firstly, Aerobotics is a Feick robotic integrator. We do almost exclusively paint, but as we're a paint robotic integrator, we actually do a lot more than that. We do the whole paint process. That means painting, scuff sanding, and then finally inspection to verify that our paint thickness was within our appropriate tolerances. So like Mark was saying, or Mark is, he was saying that with aircraft, it's extremely tight tolerances and extremely precise measuring. So all of that has to come into play here with our robotics. We do robotics all throughout the United States, and we have a couple international projects. So we do work all across the country. Most recently, we are actually starting to dive into the mobile platform systems. So the rationale for that is there's this concept, I bet you guys have heard of it from Automate this past week, the factory of the future. You want to make sure that nothing's pinned. You want to make sure that there's no permanent installations so that you can have an adaptable framework or an adaptable robot that can paint one thing one day and then adapt to do something else like sanding the next. With that, the mobile platform systems have started to come up on the rise, and that was one of our ROS systems. A little bit about me. I've been with Aerobotics for 5 years, and I graduated from Auburn University, so War Eagle to anyone out there. I've been assisting with controls engineering, robotic integration, and I've recently taken on the software development team lead at Aerobotics. So I think that kind of gives me a little bit more, a better vantage point to kind of understand each one of those divisions. So I've heard the term, I can't remember what it was, but someone was talking about it, how they're saying that you need to be a mechanical engineer, an electrical engineer, and a software developer. So that's kind of like the structure that I kind of feel like I've been tossed into. But now that we're talking about software, Aerobotics has 4 different aspects of software that we really try to focus on. One is structured light scanning, so that metrology and that inspection. So we've developed our own software for a structured light scanner, so we can maintain our own integration of inspection. From that, we can get back some model inspection data, so we can take that, compare it from between pre-paint, post-paint, pre-sanding, post-sanding, so we can use that data to help tune the process. Because sometimes our customers come to us without a process, and we need to help them discover the process with the paint or discover the process for how it needs to be finally tuned. Lastly, navigation and path planning. This is something that has been a little bit new for us, and we're dabbling and we're learning. And one of the things that we've kind of found is there's a lot of people out there who can help us with these things. And that's kind of where we come in as an integrator, and we're like, all right, so we've got all these different goals, but who can we pull in to get this goal achieved? So ROS as an interface layer. When I say that, I'm kind of talking about it's the through port for which we use or link to devices. We thought originally that it was going to be pretty straightforward. So easy device integration. It's kind of funny. One of the discussions over here for one of the roadblocks was drivers and getting access to manufacturers' data as they're coming out of sensors. We actually found it pretty easy between a couple of different manufacturers. One was the Velodyne LiDARs and the SICK industrial LiDARs. Both of those had ROS drivers out of the box that we just went, downloaded, and then bing, bang, boom, we're off to the races, collecting data. As well as the motor controllers from Zebra. They had a C++ library that we went ahead and picked up, integrated into our solution, and it was pretty quick. So if there is that ROS support, then it is quite easy to integrate. The whole structure of ROS and its air handling with the service calls is pretty robust, and so we're actually quite happy to have that as a part of our environment. And then, like I said, contractor support. Between Sweary and Hatchbed and a couple others that are around Automate, we've drank up those resources and been very grateful. What I'm in?
Yeah, sure.
So traditional robotic setups, at least from my perspective, this is kind of how we set it up. We have an HMI, we have a PLC, and we have a robot and a pate system. This is the very basic building blocks for what we have. In this situation, the PLC acts as the master. It acts as the interface for everything to talk through. If you have a question from the HMI, the PLC will answer it. If you have a question from the robot, the PLC will answer it. So when I entitled this using ROS as an interface layer, now we have an additional interface. The PLC still maintains all the communication to the robot. The PLC still maintains all the communication to our fluid system or standing system or whatever have it. But now we have this vision system that we have integrated on top of all of these standard industrial controls. So with ROS and with ROS Bridge, we're able to take that data that's a little bit more complex than normal PLC bits and bytes. So an example would be Velodyne LiDAR data. LiDAR data isn't something that you can really just take up from a PLC. It's a little bit more complex. So without having to go out and build our own UDP drivers to drink in point cloud data, we went ahead and used ROS, leveraged its drivers that some people had already integrated, and we could keep our setup a little bit cleaner. So our first example that I have is we did a mobile industrial robot, and the customer's requirements were there's a radome in a building. Radome's a part of an aircraft that does radars. And we have to plot a course from a home point to a destination point where it can begin a robotic inspection. In this example, Aerobotics was only in charge of the base. We are not in charge of the mobile arm. So we'll talk about that in a little bit. But we use ROS to handle all of the navigation and all of the motion with the floorbot. I've got a video here in a second, but the joystick controls, the planners, both global and local, and obstacle avoidance were all handled through ROS. And some of the TEB local planners and other utilities that were already a part of ROS-I. Yes, we used ROS-I. We're on Noetic. Here's a quick breakdown of how we used some of the data that was streaming back from those LiDARs. You can see here in this first image, this is just a giant cluster of data that has a giant radome that's in the middle of it. We used RViz to kind of develop some different clustering ideas. So we'll take clusters of points, we'll associate them together, we'll compare them to this STL model that we have. This STL model has a volume, and we compare that volume to the cluster point volume. And once we have that, we can crop our data to this top right image. So now we have just the points from the PLY file that we're looking for. And then we can register those two together so that we understand where this radome is in space inside the point cloud, which is then registered back to the map frame of the AGV or MIR. So here's just a little quick picture to show you like real life versus what actually happened. So I've got two videos. I'm kind of playing them side by side because one's like a minute long. Does that say cannot playback? Oh, it's a bummer. So on the right, it was actually the bot driving around, totally automated. So the first step of this process was we would take the bot, drop it in, tell it go. It would drive forward, collect that data, then it would do that cropping process that I just described, and then it would step down the length of this long tube so that it could do the robotic inspection on it. If you've never used RViz, this is a great visualization tool that you can use to pull back LiDAR data, or in this case, you also can see the AGV's path planning. So you can see well, maybe not. There's a green line, squiggly line, and then there's a purple squiggly line. The green squiggly is its global plan. The purple squiggly is its local plan. So it's one of those things that bringing this out of just software and text is amazing for me because I'm a visual guy, and being able to see it in real time was pretty amazing. So for us, we had some difficulties along the way. This was our first implementation of ROS, so we didn't really know what we were getting into. Learning about all the different services, nodes, publishers, and topics was kind of like drinking from a fire hose. Implementing LiDARs is something that sounds very trivial, but for us, you always have those baby steps of learning, how is it used? How do I use it better? What is a blind spot and why do I need to worry about that? But in situations where you're trying to navigate around objects or do other kind of path planning motion, then the more visibility you can have, the better. As well as understanding limitations of each LiDAR is also important. One of the biggest limitations was minimum range of vision. So you never think about how short you can see, you only think about how far you can see. With two of the LiDARs we were using, the smallest range you could see was 1.5 meters. So the moment any person or any toolbox rolled into 1.5 meters, boop, it was gone. So just thinking about all those different parameters and classifications of just data that comes back is always important. And then lastly, the navigation stack. If you guys have ever dealt with cost maps or anything like that, then you'll know that there are millions of parameters you can tweak. And honestly, for the first couple months, we didn't know that RQT was a thing. And so we were ripping our hair out. So RQT is one of the best utilities that you don't know about when you just start ROS. The second example we have is a part detection system. So with this, the customer requirements were, we're going to take some flight controls, we're going to roll them into a booth, and we want you to go ahead and find it with a non-contact, non-robotic motion solution. So normally with robotics, at least for us, in certain situations, the easiest way to detect where a part is just touch off on a user frame, and then you understand where that is, ready to go. In this situation, they wanted no robotic motion because they were worried about damaging parts and all the other potential mishaps that could happen from that. So what we did was we used ROS to aid in the point cloud data acquisition, and that came back from some Velodyne LiDARs as well. And we displayed that in WebViz. WebViz is a little bit different than RViz and how it functions, but it still functions through that ROS bridge service, which was really nice for us to understand. Coming from this first implementation we had with the Aerobot. I think I'm somehow missing a slide, but I can go ahead and roll with it. In this situation, we're doing a similar step process. In the top right, you can see that there is a point cloud that has been cropped down to the part. The part is associated with an STL once again, and the origin of that STL has been explicitly determined for the robotic simulation. So there's 3 different processes that happen off of one STL. You do alignment, you do simulation, and then you do actual pathing. Aerobotics didn't control the pathing in this. The customer wanted to control that, so we let them do that. But in the first 2, we're allowing maximum alignment to the part without having to try and go out there and touch it with the robot. So one of the cool things here is you can see in this WebViz display, there are TFs that are currently highlighted by the yellow lines. You can see where the Velodyne LiDAR's origin is, and then you can see where the part 0 pose, that's the origin of the part that was aligned to the point cloud. The one line that goes way out to the right that kind of disappears behind the other picture is actually the TF between the LiDAR and the robot origin. So that was the last link between getting the part from part to LiDAR, LiDAR to robot, robot back to part, so you can then go out and paint it. Oh, there's the picture. Well, anyway. So difficulties for this guy, we had so many lessons learned from the first ROS system, but the biggest one was the customer required a Windows computer, which was a very unique situation because from our first experience, it was on Linux. So what we ended up doing was we did what anyone would do is we used Linux again. So we ended up installing WSL on top of Windows, which was successful. And then the unique part about it was driver support wasn't exactly perfect. So one of the drivers that you need to do a lot of programming is graphical drivers. We didn't have a graphical user interface. We just had a terminal. So understanding how to use Linux from a terminal line and using only terminal tools like Tmux or Emacs were quite the learning curve. But everyone's up for a challenge at one point in their life, so you just gotta get in there. So that's kind of it. Do you guys have any questions? That's kind of our lessons learned in the two projects that we've really had some great success with.
Hey, Aaron. It's Matt.
Hey, Matt.
My question is like, these are two projects. What's your take on leveraging ROS?
So I think one of the biggest things that I would like to try with ROS is, so everyone here has done ROS with robotics. At this point, we've only done ROS with a floor bot. So I think getting a 6-axis robot would be extremely educational to allow us to like move further, understand more about what ROS can do, and you just use all those tools that others have talked about between Move It and Gazebo and all those others.
Somebody made it.
Yeah, so I heard someone say that today, and I wrote it down on my little checklist for things to go look up. But that does sound awesome. Yeah, to the chat, someone had mentioned something about ROS board, where you can go ahead and visualize all that LiDAR data as a part of the utility, correct?
I think someone's asking about all
So this unique thing about this is the backside of an R2000 or M900. So yeah, it's just the booty end of it.
questions to the solution provider.
You talked a little bit about your STL model registrations. What about that was alignment statement? About that problem, especially with having the excess data, you have to bring it there.
Yeah. So we kind of did this in an interesting way. So this implementation of the ROS setup was done through C++. So we went ahead and just added the PCL library side by side with it. So we could just use all those ROS service calls in line with the PCL computations. I would say it's like trade secrets, but it's just a lot of math, right? For how you actually register and crop out all that data. So one of the things that I can talk about is here at the bottom, you can see this work envelope, which is the pink zone. The work envelope was an automatic crop tool that we used. So we had a map that was clean, no parts in it. We had a new scan that had parts in it. We registered those two together. We cropped out our section of the work envelope, and then we could go ahead and crop further. If you see this blue area, if there's multiple parts, we could crop down to selected zones that were known from the HMI to have parts existing inside of it. I have yet to dive into that, but I've heard through the grapevine that there's a couple packages that you can get from Feick to allow for either a ROS bridge connection or other items. I know that there's one other package called Stream Motion that allows for remote access to the Feick, where it's just 100% remote control. But initial impressions, I'd have to read into it.
Your earlier project.
Well, so coincidentally, it was actually a CRX-10. So it was a Feick, but it's a collaborative cobot. And we were not using ROS to do the motion on the cobot. Yes, sir. So, yeah, so actually so CARTA was the system that we used. CARTA is a out-of-the-box solution that you can go buy. It has a Velodyne LiDAR, a 2D image camera, and an IMU all in one box. It's on top of the Linux platform itself. But actually you can go in, you can map a room, and then it will go ahead and register the room and register its own ODOM data by itself. And then it'll stream that back into ROS because there's actually ROS drivers for it. Correct. Correct. So that was another thing that was very educational was whenever I was learning about TF trees and learning about how the structure of that should be, there should be like a singular master. In this situation, we actually have two masters. We have Carta, which runs everything. And then once the system gets booted up and gets registered, it has its own tree, which is a dynamic link to the Carta's sensor data.
Well, Aaron, thank you so much. And thank you very much.